Okay, this video is about the two-step conversions. This is one of the last things you guys learned this semester. You guys did chemical quantities number 5, which is where you're having to use two conversions to be able to get to answers. So you'll probably be given like a word problem with a chemical equation. I didn't write this one here, but here's your balanced chemical equation. Okay. And your word problem is going to say something like this. I just made this up right now, so don't judge me. Okay. But let's just say that this is your word problem. It says 42.5 liters of oxygen react fully with hydrogen to form water. So that gives me a little bit of information. It actually gives me a given here. So anytime you see like a number with a unit, you should probably underline it there to remind yourself that you were given a given. Okay? And then you're going to be given a series of questions regarding that word problem. And usually these little sub-problems are going to help you to do a two-step conversion where you're going not just from grams to moles or from liters to moles, but you're actually going to be able to overall go from grams all the way to liters, or particles all the way to grams, or liters all the way to particles. I hope I didn't say that twice. I think I might have said that twice. I don't remember. Sorry. So, we don't have a conversion that just automatically gets us to go from liters to grams or particles to liters. But we do have a bridge, and that bridge is our good old friend, the mole. This is going to be very huge for us in January when we learn stoichiometry. But for right now, moles are the way to go. We've got to convert to moles first, then we can move to whatever we need to move to. And it's really nice, the way these problems are set up is we're actually teaching you guys how to go to the mole first and then go to something else by just asking you the first question, how many moles is this? So number 1 right here says, how many moles of oxygen reacted? So that's telling us to go from liters, what we were given, all the way to moles. So liters to moles. So I'm going to go ahead and I'm always going to start these problems by putting my given with my unit and my substance all over 1. And then I'm going to multiply by a conversion factor. My class got this. Sullivan's class got this. I'm not really sure about Mr. G or Mr. Harvey's class, but Mr. Sullivan made this little like notes cheat sheet that tells us like all the different conversions we can have. You guys you should have access to the formula sheet on your tests if you need it. That also has access, that gives you access to the conversions for grams to moles, moles to grams, liters to moles, moles to liters, etc. But I'd like to mathematically go through this with you so that you can understand why we put the things that we put where we put them. That was a weird sentence. So if I'm trying to get rid of liters and go to moles, my top right corner of my fraction, I'm going to want to end up being moles of oxygen. And if I'm trying to get rid of liters of oxygen, I'm going to want to put liters on the bottom. The reason why I want to do this is because when I have liters on the top and liters on the bottom, they cancel each other out, mathematically speaking. And so I'm left with moles of O2, which is exactly what my question asked for. Now I just need to figure out what numbers go with liters and moles. So I should know from my notes that for gas, 1 mole of a gas at standard temperature and pressure, it will just equal the volume of 22.4 liters. You just need to kind of memorize that or be able to look at your formula sheet to know that number. Okay? And then all I'm going to do, I'm going to multiply across the top. I'm going to do 42.5 times 1, which really equals 42.5, divided by 1 times 22.4, which is really 22.4. When I plug that into my calculator, sorry, I'm not showing it. I don't have it with me. It's going to end up being 1.897. I can probably just change this to 1.90 moles of oxygen. And that would be my answer for step 1. So you guys have done this over and over and over again. You guys have done this conversion here, so this isn't really anything new. But here's where CQ5 comes in, the two-step conversions. The second question asks how many grams of O2 reacted. So I can't really start with just liters, my original given. I can't just start with liters and go straight to grams because we do not have a conversion that tells us how many grams are in a liter. But we do know how to get to moles, and moles can be our bridge to get us to grams. So what we're going to use is our last answer as our given. So I'm going to go ahead and I'm going to say 1.90 moles of oxygen over 1, because I always do my given number over 1 as my first fraction. Then I'm going to multiply. And again, you can go use your formula sheet. You can find how to do the conversion. But if you can understand where these units need to go in these fractions, you've totally got this down, and you don't even need your formula sheet. So right here, if I'm trying to get rid of moles of oxygen, I'm going to go ahead and put moles of oxygen on the bottom. And then if I'm trying to get to grams of oxygen, I'm going to put grams of oxygen on the top. Okay, if I'm doing a conversion dealing with grams, I'm going to use something called the molar mass. I have a video on this if you don't remember how to do the molar mass, but you go ahead and you look at the periodic table to find your molar mass. So this oxygen right here in the equation, there are 2 oxygens. So I'm going to say 2 times the mass of oxygen. The mass of one oxygen is 16, so it's going to end up being 32. I'm going to put 32.00 grams right there over 1 mole. My moles cancel out because I have moles on the top and the bottom. And then I'm able to multiply across the top, so I'm going to do 32 times 1.9 moles. That's going to equal 60.8 grams of O2. The reason why I didn't divide by the bottom is because I'm lazy. Because the bottom was 1 times 1, it's just the same answer. So I apologize for being lazy, but that's just how I am right now. And this is going to become 60.8 grams of oxygen. So hopefully you see that the point of this problem, the point of CQ5, these two-step conversions, is that you have to be able to go to moles first to be able to switch to a different unit. We use moles as our bridge.